here's a question. If you know that a and b are integers, and a squared plus 6a plus 4b squared plus 4b equals 15, what are the possible solutions for a and b? A good way to tackle this kind of problem is a method called completing the square. So what do we notice about this problem which makes us think of completing the squared? What we see is the terms a squared plus 6a and 4b squared plus 4b, which nearly looks like squares of a plus something squared and 2b plus something squared. And we have a 2b instead of a b since it's 4b squared. And the motivation for doing something like this is because it just simplifies the equation, and that usually helps. So how do we make them actually squares? Well, the thing we'd have to fill in here to get 6a would be 3, because you have the a times 3 term twice when you square this out. But what that actually would give us would be a squared plus 6a plus 9. And similarly over here, what we'd want to get this would just be 1. But that would actually give us 4b squared plus 4b plus 1. So what do we do with this extra 9 and 1? Well, what we could do is add 9 and 1 to this side of the equation too. And then you could actually simplify it to this and this. So a plus 3 squared plus 2b plus 1 squared would actually equal 15 plus 9 plus 1, which is 25. And the completing the square step was when we added the 9 and the 1, which completed the square. So now we have a simpler equation. How does that actually help? Well, notice that since we said a and b were integers, we know that the a plus 3 and 2b plus 1 are integers. So both of these have to be non-negative and perfect squares. And there's only so many of those that add up to 25. So it could be either, this could be 9, which is plus or minus 3 squared. And then that would mean this would have to be 16, which is plus or minus 4 squared. And you could also have these the other way around. And you could also, can't forget the possibility of this is 0, which of course is just 0 squared. And 25, which is plus or minus 5 squared. And again, you could switch these. Then you could solve for each of these possible values of a plus 3 and 2b plus 1 to find the values of a and b. But to keep to the topic of the video and save time, let's skip actually computing all of this and try a different example of completing the square. So, say you had 9x squared minus 42x equals 0. So again, we want to see what square we want to complete. So the square root of this is 3x. And in this case we have a minus, so it's minus something. And 42, well, first take half of that since you always have 2 times of the middle term, so 21. And then you want to divide that by 3 because there's going to be a 3x times something. And you get 7. So this other term should be 7 squared. And now but the completing the square step would be adding this minus 7 squared term. So you can actually factor this into a square. And 7 squared is, minus 7 squared is 49. So that means to actually do this, we have to have 49, add 49 to both sides. So this would give us 3x minus 7 squared equals 49, and then you could then solve for x.